At the beginning of our program, we define the value for gravity and air density since it is a constant value. Then we define the calculation for engine efficiency as calculate ICE. For this part of the code, we use the nested if-else statement. We also use the formula for polynomial that were given in the ULEN. We assign that if the value for engine torque is greater than polynomial, the result ICE will be -1. Other than that, we use the formula for expression that were provided in the ULEN as well. We define that if the expression is lesser than 0, the result ICE will be -1. Other than that, the result ICE will equal to 0. Then, we continue to simulate and generate the CSV file, which we define all variables according to our assigned value. For the gear ratio and shift points, we put 6 values for gear ratio according to our number of gears, ranging from 0.712 to 3.958. For the initial value, we assume that all states will start at 0, hence why it is 0 there. After completing all variables, we continue with opening and reading the UDDS and hashback file. Then we continue with offstream, which is the output of the CSV file at the beginning.
So for the second part of the code here, I'm going to explain. So we're going to start with a simulation loop. As usual, you have like integer I equal to 0, I will be less than or equal to simulation duration, and then will be I++. Okay, in the simulation loop, we are going to calculate power and torque at wheel. So in here we declare the double power, double torque, and double motor torque. So in double power, we will put our variables that we get from the Excel file into this formula in order to get power and torque. So in simulation loop, we will also calculate engine speed RPM, engine torque, and resultant efficiency engine, and energy use, and also battery power. So in the simulation loop, we will calculate everything that we have to calculate in order to put into the CSV file. So we are going to continue with capacity battery power at 10 kilowatt. So for the battery power, we have like we are using an if-else statement where we have to meet with the battery power condition, and then after you do that, we will have to calculate battery current and SOC, which is state of charge of battery, using the formula that you provided in your ULEN before. And after that, you have to there's also a max capacity of SOC between 0 and 100. So there is also another if-else statement for the state of charge of battery, and there is also another multiple if-else statement which is used to calculate start voltage based on SOC. So the SOC that we calculated earlier will be put into this multiple if-else statement, so we can run our start voltage, so we can calculate our start voltage. Okay, so as you can see on this part, this is where we do the multiple else if statements, and then we're going to, after you're done calculating this, the system will be done calculating that. We will also write the value to CSV file, which is what we put in the code here, what we write in the code here. So in the output file, there will be like multiple columns with each variable that was needed in the mini project requirement. And then remember that the loop we did earlier, we will also update the variables for the next iteration, because we use a UDDS and hash FTT file, text file, and includes about 300 rows and 300 rows here. So we're going to update time, velocity, energy, the battery previous, and then will also be time. And then we have another if statement, which is to check for gear shift, as you can see here. And then after the system is done, we will then close the file by writing this part right here that I'm circling on. And then we go into the main code part, which is like to get the UDDS and HFT text file that we're going to put like manually into the folder of this code. And then we're going to call the simulation function. And that's it. So for the second part,
This is our output CSV file, where you can see there is some error in ICE, energy use, and fuel consumption. We tried to find the root cause for the error. Unfortunately, we couldn't find the root cause. So this is the graph that we compute from the table, which is engine torque over engine speed, velocity over power, engine speed over time, engine torque over time, and lastly gear over time. For the implementation of the algorithm, we use IOStream because it is a standard input minus output stream. Next, we use fstream. It is because to read, open, and close file. Lastly, we use cmat because we do calculation that include power. Next, we use nested if-else statement because there are more than one condition.
So the assumption made based on the output that we get and the first thought that I thought about when I see the project and understand how EV vehicle works is that an EV car has both worlds. What I mean by both worlds is that they can use electricity to generate like the vehicle to move, and they can also use gasoline to generate the vehicle to move. So the interesting thing about vehicle like EV car is that both worlds have limitations to it. EV car, you have to charge the car, which means that the car cannot go a really long distance, like how gasoline can be sustainable for a really long drive, like when you go from KL to Perlis or Johor to Perlis. Yeah, you just need gas and you just need to like fill in the tank just like that. But an EV car can only go for a few hours estimated. And the limitations about EV car is that in Malaysia, EV car is not really worldwide, nationwide known or used. So that's why there's a hybrid car which you can alternate. EV car can be used for like really short distance road trip, and gasoline can be used for really long distance road trip. That is why we have in the manufactured PDF, we included battery power, state of charge, and currency, and that is what we get. And by looking at other formulas online, we also found that the formula to get the battery power, the battery charge, and what we needed to put in the output. So that is the assumption made.